Okay, so test the conjecture one. Does the table represent a linear function? How do I know it's linear? Constant rate of change. You're going to find the slope 3 different times to see if it's linear. Okay, so I'm going to start right here for my first slope. I will write the formula again, but I believe you've memorized it by now because that would make me so happy. So let me label these points. I haven't been doing that. You might not need to anymore, but I find it pretty helpful to do. So my y2 is 10, my y1 is 6, my x2 is 8, my my x1 is also 6, so I'm getting 4 over 2, but I can reduce that because 2 goes into both of those. So my first slope is 2 over 1. Going to do it again. Oh, I should put number 1, number 2. My second slope, I'm going to go ahead and use these right here. Going to make this my x1, y1, x2, y2. So I'm going to get 4 minus 0 over 5 minus 3, which again is 4 over 2, which is 2 over 1. I'll switch colors for this last one. Now we've got some integers here, so let's not mess it up, okay? We've got x1, y1, x2, y2, and down here, for y2, I've got negative 2, okay? The formula says minus, so I'm going to put minus. But y1 is also negative, so make sure you write it correctly so you don't mess that up, okay? The x's are easy. It's just 2 minus 1. So now you have to remember that minus a negative means you are adding. Negative 2 and a positive 4 gives you positive 2 over 1. So all of my slopes are the same. So this is linear. Now, if you don't like doing that, you could have just plotted the points to see if the graph is a straight line. So I'm going to do it that way also in case you chose to use the graph. I put the graph here for a reason. Okay, so my first point is 1, negative 4, then 2, negative 2, 3, 0, 5, 4, 6, oops, that's not right, 6, 6, and 8, 10, which is a little bit off of the graph. So if I were to connect these points, yes, it's giving me a straight line. So if you did not write a reason, because it didn't ask you to, I want us to write in a reason right now. So how do I know this is linear? Yes. Well, actually, we did have to write it because they asked us a question, so we have to answer it in words. Does this represent a linear function? Yes. This is a linear function. Now, if you did the slope 3 times, you're going to put because the rate of change is constant. If you just chose to graph it, you would say because the graph is a straight line. So put the reason that represents how you chose to solve this one. Let's move on to test the conjecture 2. All right, so we need to complete this table for this equation to determine if the function is linear. Now, let me slide this over a little bit. So, we've done tables before. Remember, this is our x, this is our y, and the middle, I don't put the entire equation, I just put the expression after the equal sign. So, absolute value of x plus 1. And they gave us all of our x values, okay? So all we have to do is plug them in and see what we get. So instead of absolute value of x, I'm going to put the absolute value of negative 3, and I'm going to add 1 to that. Hopefully you remember that absolute value is always positive because it's measuring a distance from 0. So the absolute value of negative 3 is 3. 3 plus 1 is 4. So my first ordered pair is negative 3, 4. Put that on the graph. Negative 3, positive 4 is here. Next, absolute value, instead of x, I'm putting negative 1, adding 1. Absolute value of negative 1 is 1. 1 plus 1 is 2. My ordered pair is negative 1, positive 2, right here. Absolute value of 0 plus 1 is 1. Ordered pair is 0, 1, right here. Absolute value of 2 plus 1 is 2 plus 1, which is 3. The ordered pair is 2, 3. Absolute value of 4 plus 1 is 4 plus 1, which is 5. Ordered pair is 4, 5. Final one, absolute value of 5 plus 1 is 5 plus 1, which is 6. Ordered pair is 5, 6. So when you connect the points, you get a V. You will always get a V when you have an absolute value function. So is this linear? No. Why not? Because the graph is not a straight line. The function is not linear. Because the graph is not a straight line. I guess you also could have found the slope 3 times, but I didn't want to do that. You would have gotten different slopes though, because this slope right here is negative, but this slope over here is positive. So there's no way that they can all be the same. We're going to move on to practice problems now.